Here's an example of an operational map. In the past, they'd actually have big white pieces of paper and they'd have pen and whiteout and they'd be pinning these maps on a wall. They actually do that interactively now. But when they're pinning, they're actually opening and closing devices. What's also as important is because of smart grid, we have devices now that open and close themselves to help protect the network. So we're actually capturing that data too. So you see when a breaker opens in a substation, or you see where some switches open and close to help reduce an outage in real time. It just happens, they get alerted, they get notified, and it's there. And they can start to use this information. And we're getting a lot of data. Substations tell us what the amps are on each breaker every second. So there's a lot of data coming through the system. And we were talking about the complex event processor, using that now to help determine what the cause of the outage is. Because if you're getting information from all over the system, hopefully you can use that to help pinpoint where the problem is right away, which is always an issue in utilities, because usually you get in a truck starts driving around and looking. And at nighttime when everybody's asleep, sometimes it's hard to see where the problem is because all the lights are out anyways. So, it's also integrated directly to the schematic map, so if you're doing something geographically, the operators still like to see schematically what the map looks like. They're actually using a 10-foot wall touchscreen. They don't even use a mouse, they use their hands. It's like a giant iPad to navigate and zoom around and do some of these functions, which is quite cool. Reporting. All these reports are self-configurable, so you can report on any event, any work. All your reports are now completed automatically, as before they used to write them down in a book, try and figure them out later. So here's an example of just looking at all the pins. In this case, where are all my open points on the network? Getting your report, you can export it out, you can see it on the map, you can do whatever you want. It's also very handy if you had a big outage. What did I do in switch order terms to see how we resolve that? And the same playback we had for here, we'll be using for the pinning. So we'll see what the switches actually did in certain periods of time, which is kind of neat. So. And finally, asset analytics. So what are we going to do with all this myriad of information that we have? We have one customer, this is actually a screenshot from Toronto Hydro. They're getting 1.4 billion records every 4 days. So that's a lot of data to analyze. So 700,000 smart meters are reporting every 15 minutes. So that's 96 reads times 700,000 a day. That's a lot of information. And you really want to be able to go back and mine that and see what's happened. So here's an example of where we're just showing overloading using the Oracle heat map function in real time, seeing what's going on in the network. So as things start to heat up, the system actually notifies the operators that your feeders are starting to get overloaded, your equipment's starting to get overloaded. What are you going to do? You know, a couple hours later, okay, they're getting hotter now. What are you going to do? And at some point, you hope they do something. But they're getting information today they could never get before to actually help automate that. And then, of course, this goes back to engineering and planning to actually help build a better network, a more reliable, safe, efficient network. And here's an example of looking at 15-minute interval reads off a smart meter. This is actually aggregating up to a transformer and seeing how hot it's getting. So where it's red here, it's over 120% overloaded. So most of the day, it's well overloaded. And we can start analyzing the asset health. So in this case, as Dan mentioned, we had overloading of over 64% of the time and a loss of life of 1.11%. What's interesting is if you don't let that transformer cool down, and we'll look at a week now, it's kind of exponential how you lose the life on a transformer. So in this case, oops, that's in the wrong spot, but it's overloaded 74% of the time, and it lost 6.7% of its life in a week. They're supposed to last 50 years. They're not supposed to lose close to 10% of their life in a single week. So you can see where they get concerned about outages and equipment. And they're expensive to change. I don't know what a transformer costs to change, but a lot of money. So helping to reduce that. And of course the playback, which we're showing. So at 7 in the morning, it's kind of cool. It's a hot day. We have one transformer that's kind of hot. At 5 p.m., I don't know if you can see it here, but we have these little letters here. Those are flags coming from the smart meter saying, we're having an outage. In this case, it's a temporary outage, so the meters went out and they came back on in that same 15-minute interval. But you can actually map and now see where your outages are in real time and do something about it in restoration. And finally, this is a good case. It shows you how hot it got that evening. It's midnight, but everybody still has their air conditioners on because they're trying to sleep, so the transformers are still overloaded. With Dan's Burlington Hydro's electric vehicle work they're doing in smart grid, we really want to measure that because we've seen that plugging in one car is like adding a whole house fully loaded at 5 in the afternoon. So if you have a whole neighborhood full of electric vehicles, you're just going to blow everything up on the network. So it's important for all this stuff to feed back, not just into the utility, but the regulator, because they need to know. We're pushing forward through some of these things, and they're great, but they're going to affect how we operate as a network and what do we need to do to protect ourselves. So. And finally, just all the analytics that we looked at. So lots of different things we're analyzing with this data. So, and as Dan mentioned, for the open architecture, the ability to scale, the robustness, to get at the information, we can actually do those things quite quickly. So.
Okay, so just to wrap up, not to scare you all about electric vehicles and what they're going to do to our system, but we already have the capacity to manage that load, but that's the point. We have to manage that load, and that's what smart grid is about. We didn't go into this thinking it was an event. We knew it was more of an evolution, and we had to learn some things and discover some things and create a company, a utility company that will be able to deal with some of the advanced technology as this giant overlay happens onto the power system. And so this is the kind of system that can do it for us. We're still learning some things. You know, people don't like to let go of their paper maps. They think those things are the gospel, but we're getting there. And they get there because they see that they can do something now, and it immediately shows up to the mobile staff that's in the field. In fact, the mobile staff can do something that shows back up to the folks in the control room, and that never happened before. Safety is a very big element of everything we do, and that complements safety. It's just another level of assurance when they're doing their work. So, you know, we have one centrally maintained asset database, serves the whole enterprise. The ease of system integration, we've already seen how easily the data can be pulled together from the disparate data sets. And we have live solutions enabling the operations and sort of leveraging off this smart grid technology. And it's available to anybody that we choose to make it available to, including contractors. And we can control that access and keep it secure. On the operations side, you know, the self-healing and the management through SCADA. And of course, finally, the executive dashboard. Everybody appreciates getting accurate, timely data. This is the first time it's not perfect yet on the executive front, but it's getting there. It's getting very current, and they're getting to depend on it. So that's what it's all about. Thank you again for your attention, and be happy to answer any questions.
Any questions for Geoff and Dan on that presentation?
I'm here.
Yes, Geoff.
That was really interesting. One of the things that you mentioned was, I think everybody can hear me? Pretty noisy.
Yeah.
One of the things you mentioned was productivity, that you wanted to improve productivity. Is there any particular reason why that's important? Is it because you have to do more as part of the smart grid, or because you've got an aging workforce problem, or why is that a focus?
One example of that is we used to draft an engineering design in AutoCAD, and then we would have to redraft it into the mapping system because the systems didn't work together very well. We've eliminated that process, so now when they draft the project, the design, it's immediately available to everybody that's using the system. So that's one small productivity improvement. The engineering techs love it because it eliminates some work. And there are a myriad of other small things, but that's really what we're talking about is throughput. Yes, there are more regulations. The longer we're in this industry, it gets more complex and there's more detail. So we don't want to just simply add staff to deal with that. We want to improve the process, which really is a form of automating the process. A creeping level of automation that helps people do their jobs.
Any other questions? I've actually got a question. You know, one of the things that I take away from this is just the level of complexity. You've got a lot of systems here, and you're trying to, you know, classic integration challenge. You've got new technologies coming in. You've got legacy technologies that work okay, and you need to maintain them. You know, the data models comes to mind as sort of an interoperable data model, and I think this is sort of where the integration role comes in. It's probably a little bit of sausage making and a little bit of pixie dust. But I was curious, in the utilities industries, is there movement toward standardization or some kind of common information model to make this a reality, or is it, you know, is it all ad hoc? What's happening in that space?
There is. I would say that a lot of people are, and maybe this is a classic, Burlington was so far behind when we started that they're ahead, because they're not hamstrung with older solutions that just don't hang together yet. They've got all their processes in the company, people are using their systems. They got systems that aren't live. They don't like to transact data live, which Oracle likes to do, which is really nice. But you see the push towards, because I'm watching a project right now in Ontario, I won't name the utility, they're $100 million into a 30,000 customer smart grid pilot, and it's probably not going to work. And it's not going to work because of the systems that they have and that they've chosen. They thought they could depend on some of the older things. They just don't get them where they need to go. And we're talking, to be able to control distributed generation on a network, you need real-time information passing between multiple devices. So in the industry, there are standards. We talk about the data model, the common information model. Yes, it's there. We're toying right now with building that in Oracle. So building an Oracle Spatial actually as the standard, because it's been published. There's also an XML standard for that, for transacting not just the type of network data between systems, but the events between systems as well. So a smart meter read will fall under that. In substations, they have stuff. It's called IEC. It's an international standard, but they're all XML standards designed for bidirectional communication and action. Action meaning something happens, you can now go do something in real time in the control room. And in this case, using your map.
Yeah.
So, which is very cool.
That's very cool. Very, very cool. Okay, great. One question.
It's maybe addition to your questions. As far as I understand that the SDLs are drawn in CAD environment, AutoCAD. So then how do you ensure topology of that data?
Okay.
Since, they may connect some line to a different equipment which normally in real life that cannot happen. Is it
No,
on the AutoCAD side?
No,
or while inserting data to
right.
the Oracle
Actually,
database?
it's a little different. The AutoCAD is integrated to the network connectivity model. So there's some programming logic behind it, but while you're drawing the line, you're drawing an intelligent feature that's connecting an aversion to that elbow in that pad mount, as an example. So it's not a separate CAD file. It's actually publishing it in Oracle as you go as a version. So you can then run all your validation routines to make sure that's correct and that's what you want.
Those validation routines are on top of database?
Yes.
Or on the client?
They're sitting there with the client that they can actually do that but it's running against the central database, so they can actually validate it. So they can actually say, okay, I'm putting this in, let's do a network trace. Let's make sure A, it's connected properly. Let's make sure B, it's connected in the right way, so I'm not connecting the wrong features to the wrong thing. And it actually does that as part of the job. So it's what we've really done is just we're using an AutoCAD type tool, so people are familiar with. Great drafting tools in an Oracle Spatial environment that has all those electrical rules built in. It's really quite slick.
Part of the control is process too. Nothing goes live unless the control room makes it live, and that's why they're called the control. And so we do manage the process around the capabilities of the system.
Great. Well, thank you once again for excellent presentation, Burlington Hydro. So we look forward to seeing the continuing progress as we go forward. Thanks for being here.